So today we're going to take a look at parallel and perpendicular slopes. So ideally, what we'll be working with is still calculating our slopes, um, but we're going to start to determine whether two lines are parallel or perpendicular. So you may have seen this before, but you may not have. Just to kind of refresh our memory, if we have two lines are parallel if they have equal slopes, right? So if two slopes are the same, we know that those lines are parallel. If we look at this diagram over here to the right, we could clearly see that S and M appear to be parallel and R and N also appear to be parallel. So what we're going to do is we're going to find the slopes of each of these lines. Now, since these are on graphs, it's a little bit easier just to kind of do this graphically, kind of do that rise over run. So we pick 2 points, and you can see that they have like little dots on here. We're going to count how far up and how far over the points go for these two line segments. So I'm going to do one for R and one for N. And if you notice, it's going up 1, 2, 3, 4, 5 boxes and over 2. And it's the same thing here, up 5 and over 2. Now, since these lines are both negatively sloped, that means the slope for line N is -5 over 2. Remember the change in y over the change in x, or rise over run. And then same thing for R, -5 over 2. So this is a way for us to show that, hey, yes, these lines are parallel. Since they have equal slopes, these lines must be parallel. Now we're going to do the same thing with the other two line segments here. So we have S and M. So if I look at line S, I'm going to count how far up. So we're going up 2 and over 1, 2, 3. And I'm going to do the same thing with M. We go up 2 and over 3, right? Just counting those slopes. And since these are positive slopes, I know these slopes are both 2/3. And again, since these are slopes are equal, we're proving that these two lines are in fact parallel. So we have R is parallel to N, and the reason for that is the slopes are the same. They're both -5 over 2. And then we also have line S is parallel to line M, and again, same thing, we have equal slopes. Both of them are 2/3. All right, now just like parallel lines, we also have perpendicular lines are also really common for us to look at. And the thing with perpendicular lines is the perpendicular lines are determined if the slopes are opposite reciprocals, or sometimes we might say the negative reciprocal. Now, negative doesn't mean it's a negative. They're both negative. One's negative, one's positive, right? The negative just means the opposite sign. So here we want to find the slope of each line. And I'm going to do this again kind of graphically since they don't give us the coordinate points. But, you know, if you give the coordinate points, you're just finding the slope. So we're going to find the slope of this line AB. So I'm counting up and over until I get to like a nice perfect coordinate point. So like right here. So I'm counting up 2 and over 1, up 2 and over 3. So it has AB has a slope of 2 over 3. And CD has a negative slope. In this case, finding that nice perfect point, we got one right here. It's going over 2 to the right 2 and then down 3. So this slope has -3 over 2, right? It's a negative going down. That's 3 over 2. Now these are two examples of two opposite reciprocal slopes. So we know that there is a right angle here, right? There's this right angle here because these slopes are opposite reciprocals of one another. One's 2/3, the other one is the reciprocal, and the opposite sign, -3 over 2. So a little practice of this. The key is to understand slopes that are the same are parallel. Slopes that are perpendicular are opposite reciprocals. Right, so flip the fraction and change the sign, and we could tell that those lines are perpendicular, which means they create that right angle. All right, take a look at the practice and let me know if you guys have any questions.